Example 2, simplify 8 squared to 27 minus 3 squared to 75. Same issue as before. Subtraction of radicals is not possible if the radicals don't match. But again, looking at these numbers, I see they're composite numbers, breaking them down as a possibility. If you can do it just in your head, 27 is 3 times 3 times 3, fine. If you don't know right off the bat 27 is 3 times 3 times 3, you can do it in pieces, 9 times 3, and then 3 times 3 times 3. So either you can do it quickly or not. If you can't, again, a factor tree is always possible. But 8 times the square root of 27 can be then changed into 8 times the square root of 3 times 3 times 3. And again, the requirement of a square root is a pair. So a pair of numbers inside, we get to pull one outside. If you pull something outside, it's going to multiply by what's already out there. The last problem I had ones in front, so all we had to do was really pull the number out in front. In this case, there's an 8 in front, so we have to multiply the 3 that we pulled out times the 8 that's already there. So if I simplify this down completely, it goes to here, and then if we multiply this together, 3 times 8 is 24, and the square root of 3 is left over. We're always looking for a finished, simplified object as a single number times the square root of a single number at worst. Okay? If everything happens to pair up inside the radical, then it's no longer a square root, you just get a whole number answer, which is fine, that can happen too. But one number outside, at most one number inside. The second one, minus 3 times the square root of 75. So again, 75, 3 times 5 is what it is. If you know that, great. If not, break it apart. 75 is 3 times 25. 25 is 5 times 5. There you go. So what I do with these, with pluses and minuses, I leave a little space here with the anticipation that I'm going to be able to pull some stuff out of the radical. So I'm leaving some space to be able to put that in there. So 3 times 5 times 5 is the factor form of 75. A pair of 5s inside represents a perfect square. 2 5s in is the same as 1 5 out. 1 3 in has to stay in. And then again, I took this out. It's going to multiply by what's already out there. Minus 5 and 3 make a total of minus 15 as the integer outside. Square root of 3 is what's left over inside. Once again, I simplified both radicals as much as possible. Now I've got to subtract if possible. 3 and 3 are the same, so subtraction is allowed. 24 minus 15 is equal to 9 times the square root of 3. So again, once you see the radicals are the same, you simply add or subtract the front numbers, and the bigger number determines the sign of the answer. If I started here, and I got to here, and these numbers didn't match, then I would just circle that as my final answer. So for example, let's say I started at that point up here, and I did all my work, and I ended up getting, let's say, 7 times the square root of 5 plus 2 times the square root of 3. Let's say I started off up here, got down to right here. I can't add these together either, right? So then I would just circle that and be done with it. That'd be my final answer. So that's a possibility on these problems, that you start off here, you do all this stuff to make them prettier, but then you get to a point where they still don't add together. This is still simpler than what we started off with, so keep that in mind. That's just a hypothetical there. That's not part of the problem.